Mr. Klein here from Clare Maths. So today we're going to do my Advanced Higher Maths 2025 mock paper 2. Let's just get into it straight away. But before we do that, reminder that we've got the Advanced Higher Maths last minute live stream for exam prep for YouTube members only on the 11th of May, that's Sunday, the 7 p.m, just before the exam the night before. And it's only £4.99, so remember to click and join now. Clare Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClareLearnMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClareLearnMaths to get 30% off that. Link down below. Okay, Advanced Higher Maths 2025 last minute paper 2 question 1. Differentiate y equals the inverse tan of x squared. So that is using the start of the exam paper for this one. The y by dx, well the inverse tan is 1 over 1 plus x squared. So it's 1 over 1 plus x squared all squared times, well, I need to differentiate by x squared, so that's 2x. So that gives me 2x over 1 plus x squared squared is x to the 4. And we're done there. Advanced Higher Maths 2025 last minute paper 2 question 2. Find the general solution to this differential equation, which is the y by dx equals 4y plus e to the minus x. So that's a linear first order differential equation, but I can't do variables separate. So what you do instead is you move everything over to the same side except the function of x on the right. So I've got the y by dx minus 4y equals e to the minus x. So there's your starting position there. So now that looks like the y by dx plus p of xy equals q of x. So what's my p of x? Well, p of xy, I've got a y there, so it's just minus 4. No x, and my q of x is equal to e to the minus x. Now straight away you can actually work through the product go backwards. A much quicker way to do this is just to use your integrating factor. Integrating factor, which you hopefully you've learnt this, is just e to the integral of p of x dx. So that's e to the integral of minus 4x minus 4 dx, sorry. Minus 4 is minus 4x. So that's e to the minus 4x. So like I say, I'm just going to use this handy shortcut, which is that if you take your integrating factor and times by y, that equals the integral of your integrating factor times by q dx. So that's a shortcut, or you can do it by reversing the product rule essentially. But integrating factor is e to the minus 4x. So e to the minus 4x times y equals the integral of e to the minus 4x times q of x, which is e to the minus x dx. So e to the minus 4xy equals the integral of e to the minus 5x dx. So e to the minus 4xy equals e to the minus 5x, and then divide by the differential of minus 5x, which is minus a fifth, plus some c. Now I need to make y the subject. So y equals minus a fifth e to the minus 5x plus c all over e to the minus 4x. Let's just separate that out into a nicer fraction then. So we've got e to the minus 5x divided by e to the minus 4x. Laws of indices say that you take away. So minus 5x minus 4x is plus 4x, so that's minus x. So you get minus a fifth e to the minus x plus c over e to the minus 4x. And if you want to write that even nicer, but I'm pretty sure that would be fine, you could say that that is equal to minus 1 over 5 e to the x, plus, and then e to the minus 4x can just jump up to say c e to the 4x, and I think I'm going to stop there. Let's go to Advanced Higher Maths 2025 last minute paper 2 question 3. A curve is defined by the equation y equals the square root of 4 minus x squared between 0 and 2. Find the volume of the solid generated by this curve rotated 360 degrees about the y-axis. So if I'm integrating over the y-axis, the volume is the integral of pi times y squared dx. So that is pi times the integral between 0 and 2. Now y squared, well, that's the square root of 4 minus x squared, all squared, which is 4 minus x squared. And I've got a dx. So let's integrate that then, that's pi. 4 becomes 4x, and minus x squared becomes minus a third x cubed. Between 0 and 2, so we just sub in. So that gives me pi 4 times 2 minus a third 2 cubed minus pi 4 times 0 minus a third 0 cubed. That's pi, 4 twos is 8, 2 twos is 4 times 2 is 8, minus 8 thirds, minus nothing. 8 minus 8 thirds, and remember it's a calculator paper, but I will do this without. 8 minus 8 thirds, 8 threes is 24, so 24 minus 8 is 16. So you get 16 thirds of pi units cubed, because it's a volume. You could probably leave your answer like that, or actually I've been working it out using the pi, but I prefer exact values, so I'm going to leave it there. Advanced Higher Maths 2025 Last Minute Paper 2, Question 4. Matrices A and B are given by A is that and B is that. Quite a big matrix. Calculate AB. So some matrix multiplication. So we write them out. 2 minus 1, 0. 1, 1 minus 2, 0 minus 3 and 1 times 1, 0 minus 1, 2, 2 and 1. So when we're multiplying, we just go along each row and down. That's the first element, then along and down for the next element, and so on and so on. So for the first element, it's 2 times 1, 2. Minus 1 times minus 1 is 1, that's 3, and then 0, so I just get 3. Next element, 2 times 0 is 0, minus 2, and then 0, so it's just minus 2. And then I drop down a row, along and down. So it's going to be 1. Plus 1, because minus 1 is 0, then minus 4, and then I'm going to have 0, 2, minus 2, which is 0. And then the last elements, 0, 3, and 2, which is 5. 0, minus 6, add 1, which is minus 5. And we're done there. B says find the determinant of A. Luckily, it has to find the inverse because that would be Gaussian elimination, which can be a bit of pain, but that'll probably be later in the exam. So let's find the determinant. So A is, let's just copy this down. The start of exam paper tells you this. It tells you in the vector product section, determinant of a 3 by 3 matrix, ijk. You've got A1, A2, A3, B1, B2, B3, and it says that it is I times A2, A3, B2, B3 minus J times A1, A3, B1, B3 plus K times A1, A2, B1, B2. Now, if you've done much practice on this, you'll realise there's a pattern to this, and essentially the pattern is, it's this, then you delete the row and column, and it's times by the determinant of what's left. Then always minus the next one, delete the row and column, times what's next, and then the last one, delete the row and column, and times by what's left. So that's what I'm going to do there. So the determinant of A for this question is 2 times the determinant of, delete, delete, 1 minus 2 minus 3, 1, minus 1 times the determinant of, delete, delete, 1 minus 2, 0, 1, and then plus 0 times the determinant of 1, 1, 0, minus 3. So what does that equal? Well, that's 2 times determinant of a 2 by 2 is that minus that. So that's 1 minus 6 1 minus 6 is minus 5. Minus minus, so plus. 1 minus nothing is 1. And plus 0, of course. So 2 times minus 5 is minus 10. Add 1 is minus 9. And we're done there. SQA Advanced Higher Maths 2025 Mock Paper 2 Question 5. Find the general term of the expansion and then find the term independent of x. Formula sheet 1, binomial theorem here. And the binomial theorem says that you've got a plus b to the n equals n choose r. Well, sum of first, I equals 0 to n of n choose r. A to the n minus r, b to the r. The general term is just, well, all of that right-hand side except the sum. So in this case, n is equal to 8. A is the first term, which is 3x cubed. And b is our second term, which in this case is minus 2 over x. So for our general term, we've got n choose r, 8 choose r. A, 3x cubed to the 8 minus r. B, minus 2 over x to the r. So we're working with that. Can't do anything with 8 choose r, so that just stays where it is. But we need to, the game is, we need to get all the x's over here and then the numbers together there. Maybe even more than 1. So I'll separate my first one out into 3 to the 8 minus r and x cubed to the 8 minus r. And then the next one, now you want the same base, so your x has to be positive. So I'll just put it first like this, minus 2x to the minus 1r. And then I'll separate it out for the sake of completeness. So that's 8 choose r, 3 to the 8 minus r, x cubed times 8 minus r, where you just power rule, times the powers together. So that's x to the 3/8 is 24 minus 3r. And then I can say I've got minus 2 to the r, and then x, don't need a bracket for it actually, just x, and it's minus 1r, so minus r. And notice I've made it as x and not minus x, or you're going to mess this up because we're both just x. So that means I can combine them. 8 choose r, just writing the 3/8 minus r first, and then the minus 2 to the r next. And then combining the x's, laws of indices says same base, add the powers, so it's 24 minus 3r minus r, which is 24 minus 4r. And that's our general term, so we're done there. Part B, hence find the term independent of x in the expansion. Independent of x implies that it's x to the 0 we're looking at, because that means it was no x term. So in other words, 24 minus 4r equals 0. So 4r is 24. So r equals 6. So we're subbing 6 into our general term. So that gives us 8 choose 6. 3 to the 8 minus 6. Minus 2 to the 6. Well, x to the 0, we already know that's 0 there because it's 24 minus 24. 8 choose 6. 3 squared minus 2 to the 6. 8 choose 6, which is 28, times 3 squared, which is 252, times minus 2 to the power of 6. I get 16128. And we're done there. SQA Advanced Higher Maths Mock Paper 2 Question 6. The line L1 is defined parametrically by the equations, and L2 by those equations. Find the point of intersection. So if I'm going to find the point of intersection, I might as well make x a subject in each and make x equal x, y equal y, z equals z. So let's just try that. So for part A, we've got 4 plus 3t equals, and then rearranging x minus 3 over minus 2 equals s, you get minus 2s plus 3. And then the second one, you've got 2 plus 4t. And rearranging that, you've got 1s plus 8. And then the last one, minus 7t. And you've got 3s minus 1. So let's label that 1, 2, 3. And we'll just solve two of the equations simultaneously. So let's just do 1 and 2. If I times 1 by 4 and times 2 by 3, then that gives me 16 plus 12t equals minus 8s plus 12, and it gives me 6 plus 12t equals 3s plus 24. Take away then, 16 minus 6 is 10 on this side, minus 8 minus 3 is minus 11s, and 12 minus 24 is minus 12, so I'll take the 12 over to the other side to get 22 is minus 11s, and therefore s is minus 2. Sub it back into 1 or 2, so using 1, I've got 4 plus 3t equals minus 2s plus 3. So 4 plus 3t equals 4 plus 3, which is 7. So 3t equals 7 minus 4, which is back to 3. So t is 1. So it would appear that 1 and minus 2 work, but we've not actually tried it with equation 3, and it has to work for all three. So equation 3, the left-hand side of that says minus 7t. So when t is 1, we get minus 7 times 1, which is minus 7. And the right-hand side of it says 3s minus 1. So when s is minus 2, we get 3 times minus 2 minus 1 minus 6 minus 1, which is minus 7. So it works for all three equations. And then to answer the question, find the point of intersection. So we can just sub in t and s into the equations. So let's just use our equations up here. T or s, it doesn't really matter which. I'll just use these then. So using t, which is 1, when t equals 1, x equals 4 plus 3 is 7, y equals 2 plus 4 is 6, and z equals 7 minus 1, 7 minus 7. So the point of intersection is 7, 6 minus 7, and we're done there. Part B says find the acute angle between the lines L1 and L2. So we want some directions then. So the direction vector for line 1, we've got 4 plus 3t, so it's just 3, the number in front of t, 2 plus 4t, so that's 2, and minus 7t, so that's minus 7. And you can do the same for line 2, the direction vector for d2. Well, when it's quoted like that, it's just the bottom of the denominators, so that's minus 2, 1, and 3. So there's our direction vector. So cos theta equals d1 dot d2 all over the size of d1 times the size of d2. Just like higher maths, essentially. Dot product, 3 times minus 2, which is minus 6. 4 ones is 4, and 7 threes is 21. All over square root of times the square root of, and I'll just get my calculator for this last bit. Squared plus 4 squared plus 7 squared is 74. And 2 squared plus 1 squared plus 3 squared is 14. So minus 21 minus 6 plus 4 minus 21. We get minus 23 over root 74 root 14. So inverse cos 23 over root 74 root 14. It's 44.39 degrees or 4 degrees. But our thing was negative. So we have choose the angle there would be 180 minus 44.4. So our theta is 135.6 degrees, which is what we would usually be working out. If you think about two lines intersecting, let's say like that, you'll have one angle which is acute and one angle which is obtuse. The obtuse angle is that. So to get the acute angle, the angle is a straight line to 180. So in fact, we're back to 44.4. So the acute angle is 180 minus 135.6, which is back to 44.4. But I just thought I would show that if we advance higher maths 2025 mock paper 2 question 7. A function is defined as f of x is x squared over x minus 1. Find the equations of vertical and non-vertical asymptotes and justify your answer. Okay, so let's look at our vertical and non-vertical asymptotes. Vertical is the easy one to start with. So vertical is when the denominator equals 0, when x minus 1 equals 0, when x equals 1. So justification is undefined at x equal to 1. And then let's just look at what happens as you approach it then. As x goes towards 1 from the positive side, f of x approaches, well, if I was, what I mean by a positive side is from the right of 1. Imagine that was like 1.1, that would be positive, and if that was 1.1 minus 1, that would be positive, and that would keep getting smaller and smaller and smaller, so it approaches positive infinity. And as x approaches 1 from the left, f of x approaches, again, from the left-hand side of 1, like 0.9. 0.9 squared is a positive number, but 0.9 minus 1 is a negative number. You get negative infinity. And then horizontal or slant. So this time we need to actually take our equation and divide. So this time I need to take my equation and divide. So I've got x squared divided by x minus 1. So x goes into x squared x times. That gives you x times x is x squared minus x. Take them away. That gives you x. And then you put it in again. X into x goes 1 time. 1 times x is x. 1 times minus 1 is minus 1. Take away, you get 1. So that means you can rewrite f of x as what we got, x plus 1, plus our remainder, which is 1 over x minus 1. And this bit here then would be a slant asymptote, a non-vertical one. So non-vertical, when y equals x plus 1, and then our justification is to check what happens to infinity. So as x goes towards positive infinity, f of x tends towards, well, let's have a look. If it was positive infinity, this fraction here, 1 over infinity, is nothing. So it tends towards x plus 1. As x tends towards negative infinity, f of x also tends towards, from the other side, well, negative infinity, 1 divided by infinity is 0, x plus 1 still. And therefore, y equals x plus 1 is your non-vertical asymptote. Now, you're not asked to draw this question, but if you were, you could examine the turning points and where it cuts the x-axis and whatnot, and then draw your asymptotes in. But I'll be stopping there. If you advance higher maths 2025 mock paper 2 question 8, integrate or evaluate 1e of x cubed log of x squared. So this is like a product, so it must be integration by parts. So what's integration by parts? Integration by parts is when you've got the integral of uv dash equals uv minus integral of v u dash. So you let one of them be u and one of them be v dash, and then you integrate one and differentiate the other. So we've got x cubed log of x squared. If I was to keep, and I can't integrate that anyway, I don't know how to integrate log x. So I've got my u be this, and this be my v dash. So then my v is equal to a quarter x to the 4, and my u dash, well, that's 2 log of x times the log of x differentiated because of a chain rule, which is 1 over x. So it's 2 log x over x. Okay, so our integral, let's just call that I, which is a quarter x to the 4 log of x all squared, minus the integral of v, which is a quarter x to the 4 again, times u dash, which is 2 log x over x dx. Obviously my limits are 1 and e. So that equals a quarter x to the 4 log of x all squared minus, I'll just take that quarter x out. X to the 4 over x is x cubed. I'll take the 2 quarters out actually. Log x dx. And that's between 1 and e. So now let's just examine the x cubed log x. I'll do this in a different colour. I'm going to look at this bit. I want to integrate x cubed log x dx. That'll be my u and that'll be my v dash. So my v will be a quarter x to the 4. And my u dash will be 1 over x. So that integral equals uv, which is log x, a quarter x to the 4 log x, minus the integral of vu dash, which is a quarter x to the 4 times 1 over x, or over x dx. So that equals a quarter x to the 4 log x minus a quarter of the integral of x cubed dx, which equals a quarter x to the 4 log x minus x to the 4 divided by 4, so minus 16th x to the 4. So that means that I can now say that I, remember we called this I initially, we can rewrite that now. We've got a quarter x to the 4 log of x squared minus 2 quarters, which is a half, of the integral of x cubed log x we've just worked out as a quarter x to the 4 log x minus a 16th x to the 4. And all of this we've to sub in 1 and e. So now I'm ready to sub in because I've integrated everything. So subbing in e, that gives me a quarter e to the 4 ln e squared minus a half times a quarter e to the 4 ln e minus a 16th e to the 4. So there's my first substitution. And then minus second one, a quarter times 1 to the 4 ln 1 squared minus a half of a quarter 1 to the 4 ln 1 minus a 16th 1 to the 4. So there's my second one done. So let's just work some of that out and evaluate it. ln e is just 1, so this term here is 1. So that's a quarter e to the 4, so e to the 4 over 4. Again, ln e is 1, so we've got a quarter e to the 4 times a half, which is an eighth, e to the 4. And then we've got minus a 16th e to the 4 times a half, which is plus a 32nd of e to the 4. So there's our first bracket. And then taking away our second bracket, ln 1 is 0. That means that this is 0, this is 0. The only thing left is minus a 16th times 1. So minus a 16th times minus a half is plus a 32nd, but is minus a 32nd. So we get all that. You could work that out as a fraction over 32, say, if you wanted, out of 32 for everything. 4 5s are 26, 24, 7, 28, 8 is 32, so times in that by 8, you get 8 e to the 4. Times in the second term by 4, you get 4 e to the 4. Then you've still got a plus e to the 4. Then you've got minus 1. 8 minus 4 is 4 plus 1 is 5. 5 e to the 4 minus 1 over 32. And then you probably work that out in a calculator if you wanted to. 5 times e to the power of 4 minus 1 over 32. So for anybody that did it, that's about 8.5. And we're done there. Let's do Advanced Higher Maths 2025 Mock Paper 2 Question 9. Use Gaussian elimination to solve the following system of equations. Okay, let's just try and set this up then. So you've got 1, minus 1, 2 and 5, 2, 1, minus 1 and 4, 5, minus 2 and 7 and 19. Okay, so we need to solve that. So remember the goal here is to get zeros in this position. So I always usually row 2 and row 1, row 2 and row 3 at the same time. So my row 2 is going to become row 2 minus 2 row 1, and my row 3 is going to become my row 3 minus 5 row 1s. So being very careful, 1 minus 1, 2 and 5 is fixed. I'm doing 2 minus 2 is 0. 1 minus minus 2 is 1 plus 2 is 3. Minus 1 minus 4 is minus 5. And then 4 minus 10 is minus 6. And then the bottom one, taking away 5 from row 3, we get 0. Minus 2, and then it's going to be plus 5 is 3. 7 minus 5 twos is 10. So 7 minus 10, which is minus 3. And then 19 minus 25 is negative 6. So now we've got that position. So we then want to make sure that we get the zeros here, only using row 2 and 3. So row 3 is going to become, let's just do row 3 minus row 2. So fixed and fixed. And then we've got 0. 3 minus 3 is 0. Minus 3 minus minus 5, so minus 3 add 5 is 2. And minus 6 minus minus 6 minus 6 add 6 is 0 again. So then we can solve. So our last row gives 2z equals 0, and therefore z equals 0. Our second row gives 3y minus 5z equals minus 6. So subbing 0 in, we get 3y is minus 6. So y is minus 2. And our first row is x minus y plus 2z equals 5. So we already know that we've got x, remember that's a minus 2, so plus 2 plus nothing equals 5. So x is equal to 3. So our final solution is x equals 3, y equals minus 2, and z equals 0. And we're done there. Let's create Advanced Higher Maths 2025 Mock Paper 2 Question 10. Use the Euclidean algorithm to find the greatest common divisor between 703 and 399. B. Find the answers A and B such that D equals 703A plus 399B. And then find the answers P and Q such that 76 equals that. So 703 equal 1 times 399 plus 304. So then we take our 399. 399 equals, divided by 304, 1 times 304 plus 95. So then we take our 304, that equals 395s plus 19. So then we take our 95, that's 5 19s plus 0. And therefore the GCD is equal to 19. Part B, find the answers A and B such that D, which is 19, equals 703A plus 399B. So this is the one where you kind of work backwards. So we start at our second row and we rearrange it. For part B, we know that 19 equals 304 minus 3 times 95. So then we can move up from there and sub in rearranging the 95. So that equals 304 minus 3 times. Over 95 is 399 minus 1 times 304. That's 304 plus another three of them is 4 times 304 minus 3 times 399. And then we go up our list again. 304 is 703 minus 1 399s. So that's 4, 703 minus 1 times 399 minus 3 times 399. So that's 4 times 703. And we've got minus 4 minus 3 is minus 7 times 399. So to answer the question, 703A, 399B, A equals 4, B equals minus 7. And we're done there. Part C, find interest P and Q such as 76 equals 703P plus 399Q. Okay, let's examine part B then. Part B, we're looking at 76. And we know the GCD from the first question was 19. So how many times does 19 go into 76? 4. That equals 4 times 19. But we know 19 is already 4 703s and 7 399s. And we wanted for the part question multiples of 703 and 399s. So we might as well shove in our answer to part B. So that equals 4 lots of the whole of part B. Which is 16 times 703 minus 28 times 399. So to answer the question, 703P plus 399Q, P equals 16, Q equals minus 28. And we're done there. SQA Advanced Higher Maths 2025 Mock Paper 2, Question 11. Find the general solution to this differential equation. So we look at our Ox equation first. That's m squared plus 2m plus 1 equals 0. So we can immediately solve that to get m plus 1 and m plus 1. And therefore m is minus 1. And we've got a repeated root. And therefore our complementary function is a e to the minus x, but then we need another b, and we need to introduce an x because of the repeated root, e to the minus x. Now let's look at our particular integral. Well, that'll be of the form c e to the minus x. But I've already got a to the minus x, and if I introduce an x, I've already got a bx e to the minus x, so I need to introduce a squared term. When that happens, keep introducing an x. So now we can do y dash. So we've got a product, so I'll just take the c out so it's clear. C x squared e to the minus x. So I've got vu dash plus u v dash. So that equals c 2x e to the minus x minus x squared e to the minus x. And then we can introduce the second derivative, but we've got two products now, so be very, very careful. The first product, we've got vu dash, so 2e to the minus x, plus uv dash, so minus actually because of the chain rule, 2x e to the minus x. And then the second product, vu dash minus 2x squared, 2x e to the minus x, and then minus x squared times this differentiated, so that's going to give me a positive, so plus x squared e to the minus x. Now we can sub in. So we've got the y, d2y by the x squared plus 2y plus y. So we've got c 2e to the minus x minus, well, 2x and 2x is 4x e to the minus x plus x squared e to the minus x plus 2 lots of y dash, so 2c 2x e to the minus x squared e to the minus x, and then plus y, which is cx squared e to the minus x. And that will all equal the right-hand side, which is just e to the minus x. So let's just expand everything out and tidy this up. So in terms of constant in e to the minus x, we've got 2c e to the minus x, and that's all we've got. In terms of x terms, we've got minus 4 of them. And then you'll have plus 4 of them, so that's 0. So no x e to the x. And in terms of x squared terms, you'll have x squared e to the x here, minus 2 of them, so that's minus x squared e to the x, plus an x squared e to the x, so 0. So in other words, you just get that equaling that. And therefore, 2c equals 1, with coefficients of e to the minus x on both sides, so c is a half. So now we've got our particular integral is simply cx squared e to the minus x, a half x squared e to the minus x. So that means that our general solution, y, is our particular integral plus our complementary function. So our complementary function way back up here, a e to the minus x plus bx e to the minus x, a e to the minus x plus bx e to the minus x, plus a half x squared e to the minus x. And finally, we're done there. SQA Advanced Higher Maths Mock Paper 2 Question 12. A metal rod is heated such that its temperature T at time t minutes satisfies this differential equation, where K is a positive constant. The initial temperature of the rod is 20, and after a minute, its temperature is 50. Solve to express T in terms of T. Okay, part A. So this is one of those separate variables differential equations questions. So if I take my dt on this side, I can divide by 200 minus t, and that equals k dt. And now you just integrate both sides and then use your initial conditions. So the integral of that side equals the integral of that side. So the left-hand side gives you log 200 minus t, but be careful, because of the chain rule, differentiate that, so it's minus log of it. And that equals kt plus some constant. So log 200 minus t equals minus kt plus some constant. Now that's an e to the minus kt plus c then equals 200 minus t. I'll just get that as plus c because c is just a constant, so it doesn't matter. So then that's e to the minus kt times e to the c equals 200 minus t, and then just let a equal a to the c. So that means that a e to the minus kt equals 200 minus t. So taking the t to be positive, that's 200 minus a e to the kt minus kt. Now, initial conditions. The initial temperature of the rod is 20 degrees C. T equals 0, T equals 20. So 200 minus A times e to the 0 equals 20. So 200 minus A equals 20. So A equals 180. Next condition. After a minute, the temperature is 50. Okay, so we've got now T equals 200 minus 180 to the power of minus kt. So when T equals 1, our temperature is 50. We can sub those conditions in. So 50 is 200 minus 180 e to the minus k, minus 1. Okay, so taking the 200 over, that gives me minus 150 equals minus 180 e to the minus k, divided by minus 180, well, minus divided by minus is a plus, 150 over 180 equals e to the minus k. Let's simplify that fraction. 15 over 18 equals e to the minus k. 3 goes into them 5 times. 3 sixes is 18. 5 sixths is e to the minus k. Log both sides to do this. ln 5 sixths equals ln e to the minus k. So ln 5 sixths equals minus k ln e. So if we look back up here, it's an e to the minus k you get anyway. So we might as well just work out what minus k is. So minus k is log 5 sixths, and therefore t equals 200 minus 180 e 200 minus 180 e to the minus k, which is log 5 sixths, times t. So since we've got a log in the power position, we can get rid of that by saying we've got 200 minus 180. and that's e to the log 5/6, which is just 5/6 to the power of t. Because basically that's the same as that to the power of t. And we're done there. B, find the temperature of the rod after 5 minutes. T equals 5, so T equals 200 minus 180, 5/6 to the power of 5. 200 minus 180 times 5/6 to the power of 5 is 127.662 degrees, or about 127.7 degrees. And we're done there. This has been Mr. Colin from Clare Maths, and today we did an Advanced Higher Maths 2025 mock paper 2. Hope you found that useful. Remember the live stream the night before the exam. Members only, £4.99. Join now. Take care. Stay safe.